So we're now here to talk about the partition function, which was the 1 over z term that we put in our probability in the previous video. So one thing that we know about probability is that the sum of them has to be equal to 1. Because of course, the sum of all the probabilities has to be equal to 1. We have to get to 100% at one point. So why don't we substitute it with what we have for our function probability, that is 1 over z times e at the power of negative e power of s, e of s, divided by kt. Okay, and we know that 1 over z is not really affected by this sum, so we can take it out, and we can say that 1 is equals to 1 over z times the sum of e the power of negative e of s divided by kt. So now we can rewrite by multiplying both sides by z. Z is equal to the sum of e the power of negative e of s divided by kt. As you can see, it's pretty much straightforward. We have the partition function to be equal to just these values. One interesting thing is that you usually do not calculate the partition function for all the states. We usually just find the first few, and then you just take that value. Because again, when we have if we were to draw probability function, or just e to the power of es divided by kt, we would have a decrease, a net decrease, almost like an asymptote, a very steep asymptote. So the first few values will give you actually something real over here. But as you get closer and closer, these values are all pretty much zero. So they're not going to make any difference in your partition function, and therefore you can just ignore them. This is all you need to know about this function. There's not much to it. And now you're ready to do the problem. I hope this is helpful.